In this video, I'm going to show you how we do the mechanism for a amide formation from an acid chloride. Now keep in mind that we have a chlorine here and we're adding a nitrogen in the form of an amine, or in this case, an ammonia. When the reaction happens, we're replacing the chlorine with the nitrogen. So because we're doing this substitution style reaction, we need to include in our mechanism somewhere a nucleophilic attack and a loss of a leaving group, because every substitution requires those two steps at a minimum. Also keep in mind that we have 3 hydrogens in our ammonia, but only 2 in our product. So that means we need to do a proton transfer somewhere along the way as well. So the first step of these reactions, because chlorine is a good leaving group, these acid chlorides are great electrophiles. Um, we don't need to do any proton transfer to begin with. What's actually going to happen first is our nucleophilic attack. And we're going to add our amine, or in this case ammonia, to the carbonyl. The chlorine is not going to get kicked out yet. Instead, what's going to happen is we're going to have the negative oxygen. We're going to have our nitrogen with the 3 hydrogens, and we're going to have our chlorine. Keep in mind the nitrogen gave up electrons to form a bond to the carbonyl carbon. So that nitrogen is going to be positively charged. The oxygen gained electrons during that arrow pushing, so it's going to be negative. The next step is not kicking out our leaving group, because if we were to do so, we'd be left with a very acidic nitrogen. And so what we need to do before we do our uh, loss of a leaving group is we need to incorporate a proton transfer. So an amine will react again to deprotonate our nitrogen. So that is a proton transfer step to get us to that neutral nitrogen that we're going to have in our final product. So we're going to have our oxygen negatively charged. We're going to have our nitrogen now with 2 hydrogens, because we lost one of them during the proton transfer, and we're going to have our chlorine. The last step is going to be reforming our double bond to form the carbonyl and kicking out the chlorine. Because the oxygen is using electrons to form a new bond, it's going to go from negatively charged to neutral in the end. And so, again, we have 3 steps when we add the nitrogen to an acid chloride to make an amide. We have a nucleophilic attack, followed by a proton transfer, followed by our loss of a leaving group. Remember, for every substitution, you at least need a nucleophilic attack and loss of a leaving group. But depending on how many hydrogens you have, if there are hydrogens present, sometimes you need to incorporate proton transfers to neutralize things in the end. Proton transfers typically are done to neutralize an atom or to activate it, make it more reactive by protonating it first and then generating a good leaving group, a good electrophile, or something else. So hopefully this clarified the mechanism for the amide formation from a acid chloride.